guys, welcome to the Physical Educator. Today we're going to talk about IB Sports Science Unit 1.2, the muscular system. Before we start, if you want any other IB Sports Science videos, don't forget to subscribe to the channel. Okay, firstly, I'm going to bring your attention to the objectives. As you can see in the objectives, there's only 5, and I want you to be aware of what's on the right hand side, the assessment objectives. Objective 1 is just define. This means that for Unit 1.2.4 about origin and insertions, you're just going to have to define what them words mean. It's going to be a multiple choice or a 1-mark question. Objective 2, distinguish, annotate, outline or identify. You're going to have to go a little bit further, potentially 2- and 3-mark questions. Firstly, we're going to talk about the characteristics that are common to muscle tissue, and there's 7 that we need to learn. We're going to start off with contractility. What this word means is that your muscle has the ability to contract. All muscles contract and relax, that is all they do. Next, we're going to talk about elasticity. So when your muscle contracts and it changes length, it either shortens or lengthens, it has the ability to return to its resting length. No matter how heavy the object is that you're lifting, your muscle can always return to its resting length. Next is extensibility. This is the ability for your muscle to go beyond its normal length, so it can stretch, and after it's stretched, it can return to its resting length. If it didn't return to its resting length, you'd be left with a muscle that's too long for your limb. So it has the ability to return to that length. Our muscles are fed by capillaries. We probably remember this from GCSE. Capillaries provide the muscles with the oxygen that we need. The relationship between the oxyhemoglobin and the myoglobin within the muscle tissue, and the oxygen moves from bloodstream into the muscle tissue. CO2 goes in the opposite direction from the muscle tissue into the capillaries to be taken away, and glucose is also provided to the muscles for energy respiration, for aerobic respiration to take place within the muscles. And that again comes from capillaries that mesh like a spider's web around the muscle, massive surface area, loads of oxygen, loads of glucose, loads of removal of CO2. Next, we're going to talk about nerve control. And when you do Unit 4.2, you'll learn about the nervous system and how it works hand in hand with the muscular system. But here, every movement that occurs, every muscular contraction is triggered by the central nervous system. Think of it as any appliance that you have. Your laptop, if you took the battery out, your fridge, your TV, all of them have the ability to work, but none of them can work if they're not plugged into the wall where the electricity comes from. And your central nervous system acts as your electricity. It sends the information, it sends the electricity down your neurons to the muscle, stimulates the contraction. And that's through the nerves. Lastly, we're going to talk about hypertrophy, a word again you probably remember from GCSE PE. The word hyper means in abundance, a lot of, more, and trophy means nutrition. So if you've got more nutrition and more growth, it means that your muscles are going to develop in size as well as in strength due to the training that you do. Atrophy is a little bit different. The word "a," when it's a prefix at the start of a word, it means without, in absence of. So atrophy means in absence of nutrition, in absence of growth. So therefore what it means is it's the ability to lose mass, size and strength due to lack of training. If any of you have ever broke your leg before and your leg's been in a cast, you'll at first when you scratch your leg, you put a ruler down to scratch it. After a couple of weeks you can almost fit your hand down the cast because your muscle's wasted away and it's deteriorated. And that is atrophy that you've experienced because your muscles aren't training, therefore they're losing the strength and the size that they have. So on the screen now are all 7 characteristics common to muscle tissue. I'm not going to go through them any further. If you want to make notes on this, pause the video and make your notes on the 7 characteristics. We're going to move on to Unit 1.2.2. That is the different types of muscle, and there are 3 different types of muscle that we need to know here in this section. Firstly, we need to know about smooth muscle. Now, smooth muscle is located in the walls of your arteries and in the walls of your organs. It is an involuntary muscle, meaning you do not choose for these muscles to work. You don't eat food and then tell your small intestine to push food through it, or you don't tell your blood vessels to constrict. It's involuntary, they happen naturally. The appearance of these blood vessels, they're very narrow, non-striated, which means they are not stripy in appearance. The word striated just means stripy. So they're not striated in appearance, and they are uninucleated fibers, meaning each fiber only has one nucleus. Next, we need to learn about cardiac muscle. The word cardiac, whenever you hear cardiac or cardio, it's associated with your heart. So therefore, this is the muscle that's associated with your heart. It's located in the walls of the heart, and the strongest part of this muscle is around your left ventricle. So left ventricular muscle strength. The appearance of this muscle is striated. So this one is striped, unlike the smooth muscle. It's branched, meaning there's layers and layers and layers of muscle, and it's also got nucleated fibers, so there is more than one nucleus per fiber. It is also involuntary, because your cardiac muscle, again, just like the smooth muscle, you don't tell your heart to beat. You don't sit down, talk to a friend, and then say, I forgot to tell my heart to beat for the last 10 seconds. It's just an involuntary process that happens. It speeds up, it slows down, all by itself. The last muscle that we need to be familiar with is the most common one that we'll talk about in this section, which is skeletal muscle. Now, skeletal muscle is located all over the body. It's the muscle that is attached to the skeleton via tendons. The appearance, just like cardiac muscle, is striated, and it's multinucleated fibers. There are more than one nucleus per fiber. The contraction of this muscle is voluntary. You choose for these muscles to contract. Again, we've done in reverse with the other ones. If your skeletal muscles were involuntary, you'd just be randomly walking down the street and your arms would pop up in the air because your muscles have contracted. That obviously doesn't happen. So it's voluntary, you control it via your nervous system, and you send messages from your brain down to your muscles. The next section that we need to talk about is annotate the structure of the skeletal muscle. So we've identified the skeletal muscle is one of the 3 types of muscle. We now need to annotate the skeletal muscle. The image that's popped up to my right here, are you familiar with this picture? Can you label it? Do you know what the red dots mean? Do you know what the red lines mean? If yes is the answer, fantastic. If not, then we need to put some meat on the bones here. Okay, with this section, there's 3 connective tissues and there is 3 bundles of fibers. Before we go into them and learn the names of them, I want to look at once again at how the word is constructed with the prefix and the suffix. Prefix meaning the start of the word, suffix meaning the end of the word. I have another video on my channel about prefix and suffixes. You can check that out so you can learn about the terminology for the whole course, but these are the prefixes and suffixes specific for us now. The word endo means within, internal, so that's going to be relevant to us right inside the muscle cell. Epi means outermost in biology. It's easy to get this confused with epicenter. Peri, not from Nando's, this peri means around or enclosing. So again, within the middle, but not deep within the middle, it's enclosing. And the suffix that we need to learn, the mycium, whenever you hear myo or mycium in sports science, it's to do with the muscle. So if you put them words together, you'll be able to find out your connective tissue. We're going to start with the complete muscle. What we have with the complete muscle is a connective tissue that surrounds the whole muscle, holding it together, and that is called the epimysium. So it's on the outermost of the muscle. That's the connective tissue. What this does is holds together the bundles of fascicles which make up your muscle belly or your skeletal muscle as you know it. Each fascicle, if you dissect this muscle further, each fascicle is the next bit that's poking out. And a fascicle is a collection of muscle fibers. Each fascicle, so each collection of muscle fibers, is surrounded by a perimysium. So that's the one that's in the middle. It's enclosing each fascicle in the middle of each of the muscle tissue. And lastly, we need to learn endomysium. And endomysium is the connective tissue that surrounds the muscle fiber. And again, the muscle fibre is made up of myofibrils. We'll learn that in Unit 4.2. We won't take that any further now. As far as we're concerned, a muscle fibre is one fibre, and that is surrounded or covered by an endomysium. Remember the word endo meaning deep within the middle. So we have now 3 connective tissues and 3 layers of muscle. And on this last slide, what you can see is this in its entirety. So the top picture is demonstrating the whole muscle as we know it. The epimysium is around the outside. Each of them fascicles that you can see in that top picture are surrounded by that white connective tissue, and that is called perimysium. Each fascicle is made up of a bundle of muscle fibers that's surrounded by perimysium, and each muscle fiber surrounded by endomysium. Also, a nice activity for you to do here to remember these key words is to make your own skeletal muscle. Now the way that you do this, you only need the resources that are on the screen now. To make this, you simply put a little bit of paper around a bundle of muscle fibers, the crayons, to make fascicles. As you can see here, I've got 3 fascicles, and each fascicle is held together by a piece of paper, and that's the perimysium holding together this fascicle. I slot them fascicles together to make the complete muscle. I pull out a little bit of the crayon cover to release the muscle fiber held together by the endomysium, and the epimysium holds it all together. It's a great little trick for you to learn these 3 layers of connective tissue and the 3 layers of muscle bundles. Give that a go. Moving on to unit 1.2.4, all you need to do for this unit is define the term origin and insertion. You can see this diagram on the screen next to me. It's an example of the shoulder holding the bicep, and what's happening here is the muscle, the bicep muscle, has a tendon at the proximal end here and a tendon at the distal end here. Them tendons attach to bones, and they do one of 2 things. They either stay still and stabilize the movement, which is the origin, or they insert into the moving bone, which allows the movement to happen. So the origin stabilizes the movement, so it doesn't move. It stabilizes the contraction and stabilizes the movement. So for the bicep, this is the scapula here, holding together the bicep as it contracts. As the bicep contracts, it's the forearm that's moving. So insertion means inserting into the moving bone. So the insertion goes from the tendon, and if you grab your hand into your elbow, you can feel wire, quite strong wire. That's your tendon, and that is attaching to your bicep, running across your elbow and attaching to your forearm. So when your bicep concentrically contracts and shortens, your forearm moves upwards, causing flexion at the elbow. And these tendons attached to the bones help that to happen. Originating here, stabilizing the movement, not causing any movement, and the bones don't move. Insertion, inserting into the moving bone, and that's the movement that takes place. So 1.2.5 is talking about the location of the muscles and where each muscle originates and inserts. We're going to start with the muscles in the upper body, and we're going to start in the arm. So the biceps brachii, the origin is the scapula, holds the muscle in place, so when it contracts, it can insert into the radius and the ulna and cause flexion at the elbow. If you dig your fingers into your elbows on the inside, you can feel like a wire in there. That is your tendon that runs from bicep to radius and ulna. On the back of your arm, you have your triceps brachii. Again, tri means 3. So there's 3 heads to this muscle. They originate at the scapula and the proximal end of the humerus, holding that together. It's a bigger muscle, therefore there's a bigger surface area for the origin. This inserts into your ulna on the outside of your arm. Again, if you tense your tricep and you feel your thumb side, you'll feel it quite loose. If you feel your little finger side, you'll feel it quite firm, and that is the tendon that you can feel. There is 3 muscles in the upper body that all insert into the humerus, and that's what we're going to look at next. Pectoralis major, the origin is the sternum, the ribs, and the clavicle, holding that muscle all together. A big surface area because it's a big strong muscle, it's a major muscle. It inserts across your shoulder into the medial aspect of your humerus, and this movement is allowed, adduction, because of it. As the chest contracts, your arm moves in. pectoralis major. The second muscle in your upper body that inserts into the humerus is your deltoid. Now your deltoid, the origin is the scapula and the clavicle, holding that muscle in place. The insertion point is the lateral humerus. So therefore, abduction is allowed. As the deltoid contracts, your arm abducts. If you move forward into flexion, it's still the outside of your muscle that's causing that to happen with the insertion into your lateral humerus. And even when you do that movement, you do tend to rotate your arm in, so your lateral humerus even faces forward as you make that movement. The third muscle that inserts into the humerus is your latissimus dorsi. Now this muscle works a little bit upside down. The origin is further down the body. It's the top of the pelvis at the ilium. It's the sacrum, the lumbar and the thoracic vertebrae. Again, a massive surface area because it's a major muscle group. It inserts into the medial humerus, just here. So this movement is allowed. As your latissimus dorsi contracts, it will pull you back in. So either a pull-up or even if you're rowing, it's the same movement, but your arm being pulled back towards you. The last muscle in the upper body is the trapezius. The trapezius, the origin is at the thoracic and the cervical vertebrae, again stabilizing the muscle. When it contracts, it moves the clavicle and the scapula, so they are the insertion points, and this is the movement allowed. Next, we're going to talk about the muscles in the trunk of the body. Now, before we do so, the pelvis is key for origin insertion points here. On the screen is a picture of the pelvis and the different bones within it. We mainly need to focus on the pubis and the ilium. Okay, so we'll start with the rectus abdominis. The origin is the pubis, so it's deep within the pelvis. It inserts into the 5th and 7th rib and your sternum. What happens when the rectus abdominis muscles contract? Flexion in the torso, flexion in the spine. From this position, our erector spinae help us. The origin for your erector spinae is your ilium, out wide in your pelvis, all 3 sections of your vertebrae, lumbar, thoracic and cervical, and your ribs. Your insertion points are exactly the same except the ilium. The ilium is the only bone that works purely as the origin. The others are both origin and insertion here. And what they do, the erector spinae, when they contract, they allow you to straighten your back. Your external obliques. The origin for your external obliques is your lower 8 ribs and the insert into your ilium. So again, as we contract your external obliques, side movement happens, challenging your obliques, and you can really feel the burn in that area there. The last muscle in our trunk is our iliopsoas muscle. Now this is a muscle group made up of 2 muscles, the iliacus and the psoas major. When they're together as the iliopsoas, the origin is the lumbar vertebrae and the ilium, and it inserts across to the medial femur at the proximal end. And they're the muscles in our trunk. And finally, we've got the muscles in the lower body. We're going to start with the gluteus maximus. It's a big, strong muscle, so it has a big origin. Your posterior ilium, your sacrum and your coccyx provide a big origin with a big surface area, and it inserts into the lateral femur, gluteus maximus muscle. Going into your legs, we've got your quadriceps and your hamstrings. And these key things to remember with your quadriceps and your hamstrings to do with the origin and insertion that you will get asked on your exam. The quadricep, all 4 muscles insert into the patella and the upper tibia, all the same. It's where they originate that's different. You can separate your quadriceps into 2. You've got 3 vastus muscles and your rectus femoris. Now your 3 vastus muscles, vastus medialis, vastus lateralis, and vastus intermedius, they all originate at the femur. The one that's different is the rectus femoris. It's the biggest quadricep muscle, it's the one that works antagonistically with your hamstring, and it also originates above your femur in your ilium. And this connects your leg to your trunk, allowing these movements to happen, rectus femoris. So a simple exam question could be a diagram with an arrow to a quadricep muscle that's originating in the ilium. You know it's the rectus femoris because your three vastus muscles originate in your femur. To your hamstring, there's a similar concept here, but instead of it being different origin points, it's different insertion points. All three of your hamstring muscles, they all originate at the ischium, the lowest part of your pelvis. Apart from the biceps femoris, again, the one that works antagonistically, your biggest hamstring muscle, doesn't only originate at the ischium, it also originates at the femur, bigger surface area, bigger muscle. Again, we can separate our hamstrings into two. We've got our semitendinosus and semimembranosus, and both of these muscles originate at the ischium and they insert into the medial tibia, the semitendinosus being the smaller one of the two. Your biceps femoris inserts to your lateral tibia and your fibula. Again, slightly bigger surface area, bigger muscle. But it's these insertion points that are different. And if you have a diagram on your exam, you'll be able to distinguish between the two. Going underneath your knee, we've now got three muscles. We've got your tibialis anterior. And if you think about what this muscle is called, it's the easiest one to remember. Anterior, it's at the front of your body, and it's called tibialis. It originates your lateral tibia. It inserts into your first metatarsal bone, here. To the back of your legs, we've got our gastrocnemius and our soleus. Both calf muscles insert into the calcaneus bone in your tarsals via your Achilles tendon, but the difference is where they originate. Your gastrocnemius muscle, if you're to do a calf stretch, you can feel the strain above your knee, and that's where it originates, at your distal end of your femur. If you drop your knee down, you can now feel this stretch in your soleus, and you can feel it deep in your Achilles tendon and just underneath your knee. And that is where the soleus originates, at the upper part of your tibia, posterior end at the back. And that's the difference between the soleus and the gastrocnemius muscle. One final muscle is a stabilizing muscle, and I've seen this on the exam a number of times. Your sartorius muscle is a thin muscle, very small muscle, that originates at the ilium, and it goes across within your quadriceps and hamstrings and inserts to the medial tibia. And like I said, I've seen this a number of times, so make sure you include that in your studies when you're looking at all the muscles in the lower body. Good luck with your studying. For any more IB Sports Science videos, don't forget to subscribe to the channel, and I'll see you again soon.